You cannot break the computer based on this. Okay, so I separate in two areas. One is more interesting area, the user space memory. Okay, so what is the stack, what is the skip, what is the code, blah, 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 okay? And this is more interesting because I will use the program to teach you how to use segmentation faults effectively in order to prove something. I can go to the end of the slides to tell you what is it. Okay, so the thumbnail. Okay. Whoa. Okay. So take a look at this program. This program, you know what it is, but I manipulate the knowledge that you will gain through this chapter. See what is the thing that I handle? I handle segmentation faults. And I control the memory access by using a for while loop, and hope that I will generate segmentation faults. Yeah, I try to generate segmentation faults, and what this program is doing is to measure some part of the memory, and we call it the code segment, where the code segment stops. I use this program to do a measure. Okay, so this program later on is an 80-something page. I will teach you. So it is too advanced. Okay, I will jump back to the page 1. And what is the system memory? And I should say system. Okay, it's user space memory. Okay, it's this guy. You already seen it a lot in previous chapter 2. Okay, chapter 3 we saw this. Yeah, we go back to this 4 guys. Okay, and one of the 4 guys, some people may find it hard to understand. So I will start with something easy, the code. Then I will go to the global variable. I will tell you some inconvenient truth about global variable. Then we will go to local. Local is a stack. And the dynamically allocated memory is a linked list, actually. Okay, you call malloc action, malloc generate a linked list for you. Okay, and we can add that linked list. All right, so what is this about? First of all, again, I cannot believe that, okay? Some people tell me that in data structure course, you set up this pointer. Yeah, why? Because you can hardcode an array, you can pass a join, you can pass a test case, okay? And you never use pointer a lot, right? Is it? Yeah, okay, I can stop recording. You can say yes or no, huh? Yeah, in data structures, you seldom use it, okay? Even though you're using the tree, yeah, I can use an array to pretend to be a tree, okay? Yeah. Then we have a problem. So I will teach you some basic stuff first. Address it. What is this? Yeah, it seems too hard to understand. Don't worry. I first execute my version, okay? So what is this program? This program is this in the GitHub already. It should print several addresses out. So first of all, something that you may think that hard to believe or hard to understand. Now, what is this guy? Okay. So this guy is malloc. Okay, we don't know what is malloc. Huh? Yeah. Okay. Let me ask another question. What is the relationship between new and malloc? Oh, don't know. Right. What is new in Java and C++? Huh? No, Java. Suppose some, right? How about C++? They have new, right? And actually new is eventually to create something called objects. They contain data, contain functions, okay? And the truth is, it's just malloc. Malloc to create an area to put the variables, to put a function pointer, in order that to cheat you guys that there is a field for a function, you call it, actually you forward the function pointer. Okay? So, but don't worry about those terms, okay? We won't go there, okay? We have this bunch of things. First of all, the malloc pointer, before you put an address inside it, okay? It should be something random, but I'm not interested in what they are inside. More interesting stuff is about its address. So I want to print out address using %p. %p is between pointer address. Okay? Use an and there. So that means that I create an address of a variable. And the variable so happens to be a pointer. So if you don't understand what I'm doing, I am looking at the local variable's address. So you must think when I said local variable, the local variable's address. Next, I look for the malloc pointer, the value inside it. So what is the value inside it? It is being generated by the malloc call. The malloc gives me new area of memory 4 bytes, and I save it. And if you don't know what it is, I can tell you it's actually a bunch of memory, and the return value is addressed to the start of that bunch of memory. Okay? So this should be storing something related to the malloc. Global variable, I have global variable here. I should move a bit. Okay. Good. So the global variable, I will also print out the global variable address. So this addressing programs, okay? So I don't care about the values here. And what is this so-called constant pointer? I have a constant create here. So this is a constant string. Okay? If you are using Java, then you should understand what is a constant pointer. Okay? You can use a string pointer equal to a constant, but you can also use a string pointer equal to a new string. Okay? It's totally different. If you don't understand this, you forget about it. It's a constant, right? And last, what is it? I asked you this question. What is the last question? Last, call and constant equal to, and I print main. Function address. Function has an address. And actually, we usually don't call it function address. We call it function pointer. Okay? And every function inside C has an address. Okay? So we can put it here and say that I want to print out the address of a function. Any questions about those code? Okay? I didn't execute anything yet. So I make it a little wider because we have several lines of outputs. Okay, so what can you say about this output? I will only interested in their relative position. Who is smaller, who is bigger? Okay, so who is the biggest? Who is biggest? Local. Local is having a bigger address. Who next? Malloc. Okay, the area that created by malloc is just not just, okay, some order already. Okay, smaller than local variable. Then who's next? Who's next? After the malloc? Global. Global. Okay, global is here. The code and constant, they are quite close. Code, there is a function pointer of main, as well as the constant, they are very close together. And actually, what I'm going to show you is why I print those address. I want to show you this map. I want to show you this map. Within the address area of a process, they are aligned this way. The global variable, the highest address. Then close to it, we will have the heap, or we call it dynamically L in the memory. Okay, and the gap between them, between the global and the heap, is very big. You can take a look here. Yeah, by several degrees. Okay, wow, several order, I should say. By several order, then you reach the global variable, and you can imagine that my figure here is not drawn to scale. This pink area is huge. Maybe in the reverse, the global variable is huge. But I don't know where the malloc, maybe malloc is here, okay? Or the malloc is here, I don't know. Okay? But you can see there's a huge gap. Later on, I will tell you, keeping you updated with the gap, where it's about the gap, how can I allocate memory from that gap for the global and for the heap. Then the heap, after that is the global, and after it is constant and the code. Okay? So now you understand that within a process, it's a layout. Okay? It's a layout. And the layout usually is the same when you are using Intel CPU. If you change another CPU, the layout may be a little bit different. Or you change from 64-bit to 32-bit CPU. Both for Intel, they already show you some difference. Okay? So this is something hard to swallow. Give you something easier to swallow. Let's say in a 32-bit system, 32-bit system. And what is addressing? The addressing is we have 32 bits. We have 32 bits, and the 32 bits addressing means the biggest address is the biggest address that we can support is 8F. Why is it? 1F is 4 bits. 4 bits. 4 bits. And 4 times 8 is 32 bits. Okay? So the biggest address is all set to 1. And you do some transformation and you understand it is 4G minus 1. That means what? That means under a 32-bit CPU, every process can allocate at most 4 GB of RAM. Only 4 GB. Okay? You can ask those bits, those supercomputer kind of value. Oh, yeah, only one here. Okay? You can ask them. They never use 32-bit CPU. They use 64 bits. Because their computation involves more memory than 4 GB. And let's imagine that if you go to 64 bits and you do the same calculation, how many RAM a process can have? I mean one process. I mean not only that system. Okay? This calculation is for one process only. And that means when you have 32-bit CPU, you insert 128 GB. The CPU is full. Yes, as long as you are not computing too much thing, okay? If you want to create a huge process, no use. You can create many process, and those consume huge amount of memory, like 3 GB. You create many 3 GB process. But you cannot create one process that can take all 128 GB. Okay? So understand this. This is very important. Now change to 64-bit, then you can have a process using 124 GB memory. And why you have such a control is because the address that we use is 4 byte in 32-bit. That's all. It's not about an operating system put a limit there. No, the limit comes from the CPU. The CPU take an address which is 4 byte, and in 64-bit CPU, its take address. What is that? 64-bit divided by 8 byte. Okay? So this is the fundamental difference, and that fundamental difference gives you some headache if you're nowadays it's very few people still using 32-bit, right? Let's say the headache is you want to do some allocation, memory allocation, and do some I don't know what is your application, but you get some memory limit, and the limit is from the CPU itself. Okay? So remember this, because of this, okay, we sometimes need 64 bits. And even some more basic thing, instructions, okay? I don't need to tell you all things about instructions because, because nowadays you guys CSCI quotation 3420, right? Yeah. You never heard of the rumors about 3420. And ask your senior, okay, they will hear some rumors about 3420. Okay, 3420 will teach these guys, okay, how to write semi-code, okay, how to write machine code, transform the machine code. Well, right, okay, right, semi-code, so and so forth, okay. So, sorry. What is this diagram? This diagram is to tell you if you know what is assembly, okay, then you will find pointers very easy to understand. If you don't know what is assembly, then you will find what is pointer so hard, okay? So I will give you a 5 minutes super quick course on what is a pointer. Super quick. Okay, 5 minutes, I don't have too much time. Okay? What is a pointer? A pointer is a storage, 4 bytes in 32-bit CPU, in 64-bit CPU, 8 bytes. That's all. This is an address. Storage to store address. Yeah, I mean, it's circular definition, right? Address storage to store address. Okay. You don't find it circular. And what is that? It is just to save the address whenever you store address. Okay, you have an address. You can use the I missed out. I missed out the example. Okay. Don't worry. All right. So I create this program is haha, okay. haha.c. Yeah, really, because it's quite hard. Okay, remember that this is a place for storing address, so I can type something random. How many? 1, 2, 3, 4, 5, 8. Okay. So I write a random number here and treat it as an address. No problem. Then what is this operator? This operator, asterisk, this pointer. It means I follow the storage 1, 2, 3, 4, 5, 6, 7, 8. I go to the memory, allocate it to my process, and I try to reach this 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. I go there and treat that guy as an integer, take it out, check it out, okay? Become an integer, treat it as an integer type. That is a pointer, right? Just play with addresses. I give an address, you follow that address, go to that place. Save it, compile, run. It's already complained to me. Yeah, man. Yeah, I go continue. Segmentation fault. Okay, why? Because this guy doesn't exist. Okay, try another one. I create a global variable. Now I want to try one thing. Okay, so bear with me for a while. Global variable. I have no auto completion. I should make it smaller. Print it. I need to do some experiment first. Okay, every time is close to that range. Okay. Let me copy this. You know what I'm doing to do, huh? You guys are naughty. The reference. I don't know what will happen, huh? Don't ask me, or we represent X, okay? Don't ask me what will happen. Because the first time is this address, the second time is changed, okay? So then I copy the previous time. I don't know whether I still get that address. Okay? Put a signature there. COX. Okay? Put a signature there so that I recognize it. Compile. Run. Missed the target again. No. What happened? Why? I'm so frustrated. Okay, don't worry. I have one more way to do it. Okay. Percent P. Yeah, you know what I'm doing. And scanf. Yeah. Yeah, you know what I'm doing. Okay, very nice. And side long x scanf percent lu and x. Okay, we tell 0. Oh, sorry. No. It should be LX. Is it LX? I want to scan in a hexadecimal number. Yeah, anybody give me assistant? If I want to scan a long hexadecimal number, is it? Yeah, I don't care. Try. Go. 100B2. Okay. Go. Yeah. Read something. I don't know what is that. Yeah. Do I need to input COX again? I don't know. I didn't try. At least it's made something. Yeah, better than none. Yeah, really better than none. Okay. So yeah, you see what I'm doing, right? I'm manipulating a program memory. Okay. And this is the only thing that C is fun about it, right? when you use reference in C++, you cannot do it. Okay? Using Java, Java sucks. No? You know, create a so-called reference. Actually, it's the pointer. Okay? It's just a pointer. Okay? And create some hash value to cheat you is a pointer address. Okay? Yeah. So in the next lecture, I will try a lot of program. Okay? I will execute this type of program in front of you to tell you some truth about program. So if you really want to follow my lecture, you are welcome to bring your laptop. Okay? Let's say in this program, can you say anything about this program? This program is interesting. What is this program? What this program is doing? Can I compile this program? Yeah, that's why I said that next time you need a laptop, right? I'll keep on asking you this kind of question. I create a strange program, ask you whether I can compile it. I can guarantee you that this program is compilable. Okay? But what is the effect that you will run and give the results? Will the results change hello into hell? Yeah. Yeah? So, you got the correct answer? Okay? So, how many of you don't know what I'm talking about? What? How to count? Yeah. Okay. Trace the program. I'm changing the fifth character. Okay? But this fifth character is from a constant. So, starting from the next lecture, I'll keep on doing this kind of trials. Okay? If you want to try it out, make sure you have a Linux or Mac. Okay? I try out most of operations are the same for Linux and Mac. Okay? So next week we have a problem.